Hey there, before we get started with today's lesson, which is 10.3, I want to take just a minute to go back and discuss what you did on 10.1 and 10.3. I'm sorry, 10.1 and 10.2. In 10.1, you discussed the distributive property. In 10.2, we discussed factoring. Another word for factoring is expanding. So when you see the phrase expanding a problem or an expression, that means you're going to factor it. When you distribute, you're multiplying what's on the outside of the parentheses by every term on the inside of the parentheses. So that leads us now into 10.3. Our central question is, how can I combine like terms to create equivalent expressions? And we're going to be working with adding algebraic expressions for this lesson. So if you'll get this stuff copied down into your notes, and again, if you'll pause and start the video as needed so that you can get down what you need. All right, we're going to start with adding algebraic expressions. We already know what an expression is. We talked about the difference between an expression and an equation in the video the other day. All right, several things I need you to have down. What are terms? The terms are quantities that add to form an algebraic expression. They are called the terms of the expression. I don't want you to copy that part down, but the part I want you to copy down is this right here, what I'm going to type. And I'm going to make this a little bit smaller so that you can see it all. What I want you to have is that terms are separated by addition and subtraction signs. So, for instance, if I write the expression 2x plus 6 minus 5, and let me make that a little bit smaller. All right, so I have 2x plus 6 minus 5. These right here, this expression has three terms. The reason it has three terms is because if I look at what's separated by my addition and subtraction signs, here's my addition sign, here's a subtraction sign. I have that 2x, the 6, and that 5 separated by addition and subtraction signs. So this problem has, or this expression has, three terms. Next thing is coefficient. Most of you know these things already. A coefficient is the number factor of the term. Another way I want you to think about it is the number in front of the variable. And that's what I want you to have now. Coefficient is the number in front of the variable. If a variable does not have a number in front of it, it's understood to have a coefficient of 1. For instance, if we have x, our coefficient is understood to be a 1. Okay? So 1x is the same as just x. Next thing is our constant. I believe most of you probably know what the constant is. The constant is just a term without a variable. It's just a regular number. For instance, the number 6, it is a constant. The value of 6 is not going to change. It's constant. The value of 7x, our variable's x, our coefficient is 7. This value of this right here is going to change based on the value of x. If x equals 2, the value of that term is 14 because 7 times 2 is 14. If x equals 5, the value of that term is 35 because 7 times 5 is 35. So the value of this term, because of that variable, changes based on what the value of that variable is. Whereas a constant such as 6 is always 6. 8's always 8. 1/2 is always 1/2. So a number without a variable is called a constant. Now down here, we have coefficient that we have is -5. The y, our coefficient, would be understood to be a 1, and our constant is 2. And we have 3 terms, because those are the 3 things separated by the addition and subtraction sign. All right, what I want you to do is to draw this table, please. You're going to have about 5 more things going across the top than what you have here, about 4 more. So the first one is 12a minus 3. So yes, I do want you to have everything down in this table. All right, I'm going to do this first one for you before we get started, or before we can I'll let you move on to the next one. Number of terms, I have 12a minus 3. I have 1 minus sign. The 2 things separated is the 12a and that 3. So the number of terms I have is 2. My coefficients, I have 1 variable. My variable is a, so my coefficient is 12. My constants, what you have to do when you're finding your constant is you got to be careful to make sure you take the sign in front of it. My constant is not 3. My constant is negative 3. All right, so what I want you to do is I want you to complete the rest of the table using these expressions up here. So if you'll do this one, this one, this one, and the remaining. I'm going to put a star here to make sure we go over this. All right, next thing, identify the number of terms, the coefficients, and the constants of this expression. All right, so what I want you to do is tell me the number of terms, the coefficients, and the constant, if there is. I'll just ignore that bell. All right, so if you will do this with 6p minus 7pc plus 9c minus 4. All right, moving right along. Now let's get into the adding the algebraic expressions. Question, how do I add algebraic expressions? This is a very simple concept. You know what a term is. Most of you know what like terms are. Like terms, they have the same variable. So let me go ahead and highlight this, because I want you to copy this down. We're going to identify like terms. They have the same variable, and the variables have to have the same exponents. So an x squared is not a like term with an x, because they do not have the same variable. An x squared would be a like term though with like 6x squared, because they have the same exponent and variable. Second thing we're going to do, and I'm going to put a question mark here because some students like to do this. I'm not too picky on this. I don't really do this, and it's just my preference. Regroup the terms with like terms together, and I'll show you what I mean by that. Next step, we're going to combine our like terms. So let's take this example, negative 5x plus 4 plus 11x minus 9. First thing we're going to do is identify our like terms. So I'm going to underline. I have a negative 5x. What makes a like term with that negative 5x would be another term with an x. So I have an 11x, so those are like terms. Now I have a 4. 4 is a constant, so I'm going to underline that twice in blue. That's going to match up with any other constant that I have. So I have a negative 9, so I'm going to underline that with blue. So I've taken care of step 1, identifying like terms. The second step, like I said, it's not something I do. Some students like to do it, is to regroup the terms with like terms together. What I mean by that is they just rewrite it. So what you might do is say negative 5x. Let me get my board working. They might say negative 5x matches up with an 11x. So they're going to put those together. And then I have a plus 4, and I have a minus 9. So what I've done is I've regrouped these with my like terms put together. So I've taken care of the second step. My third step now, we're going to combine our like terms. This negative 5x, that 11x are like terms. If you recall, to the beginning of the year, when you combine terms for adding and subtracting, if they have different signs, this is a negative 5x. Positive 11x, we're going to subtract. 11 minus 6, 5 is 6. So that gives us 6x. Take the sign of the bigger number. 11 is bigger than 5, so it's a positive 6x. Same thing here. I have a positive 4, negative 9. Different signs, so I subtract, so that gives you a 5. Take the sign of the bigger number. 9 is bigger than 4. That gives me a negative 5. 6x minus 5 is my simplified form. Those are not like terms, so this right here is your answer. We have now combined like terms to complete the step. And if you will, please copy down this expression. All right, next thing. If you will work these three, please. Actually, these three, I'm sorry. If you'll take these three, work them out, and obviously your answers are going to be up here. Put a star here, so we'll know to go back to it. All right. What I want you to do is just work these 4 problems. Pay attention to number 3 and also number 4. You're going to have to distribute. On number 3, you're going to distribute that 5. And on number 4, you're going to distribute this 2 in front of the t minus 3. So if you'll work those 4, put a star there. All right, this next example. Now, I know I'm going kind of quick, but what you have to do is pause the video. All right, next thing. The perimeter of a rectangle is the sum of the length of its 4 sides. You can use this formula for the perimeter of a rectangle where L represents the length and W represents the width of the rectangle. Now we know a perimeter is adding all sides together. So I have 4 sides, so that'd be like adding W plus L plus L. I have 2 W's, so that gives me 2W. I have 2 L's, that gives me 2L. And that's where this equation or formula comes from. All right. Please let me know if you have any questions with this. Now, what I want you to focus on in this part is where did that 2W and 2L come from? Now, when we're combining like terms, we add the coefficients. So 6x plus 3x, that would give us like 9x. Whereas right here we have W plus W. As you'll remember, a few minutes ago I said if a variable does not have a coefficient, it's understood to have a 1, so I add the coefficients, that gives you 2W. Same thing with the L's. I can put a 1 there. 1 and 1 give you 2, which gives you 2W plus L. All right, this one. A rectangular frame for a flower bed is 9 feet longer than its width, than it is wide. Write a simplifying algebraic expression for the perimeter of the flower bed in terms of the width, W of the flower bed. Now, this is the type of problem we're going to expect you to be able to work. It says the rectangular frame for a flower bed is 9 feet longer than its width, than it is wide. Okay? So write a simplifying algebraic expression for the perimeter of the flower bed in terms of the width W of the flower bed. So, what I want you to do is write down the important information. You don't have to copy this word for word, but I'm going to just highlight it so that you'll know to copy down the important information. And then we're going to come back and see if you have any questions on this one. So give this one a shot. All right, this right here, core bites. I don't think we've done a core bite in this class. So what I want you to do with these core bites, you're going to have these periodically. I want you to go through and work 1, 2, 3, 4, and 5. You don't have to copy the problems down, but if you will go through and work these 5 problems. So you may have to pause the video. All right, now this is the last part. I want you to work on these. I'm going to write do these and highlight it. So if you will do these problems right here, please. And if you'll copy them down, and again, this is something that we're going to go over.